Supposing I had this declaration. What would you say that one says? Student splat XPTR. Other than just reading what I said, what would you say XPTR is? Cannon? Pointer to a student, or in this case, a student type. Now, do we have a location, do we have any actual memory to point at yet? Nope, unallocated. It's just the declaration of the variable. Okay? Justin?
I was just wondering, are we going to have to worry about like instantiating, creating an instance of?
Yeah, we're going to do that right now. Okay? So we're going to say XPTR equals new. Now I want to dynamically allocate this thing. New. Finish it up for me. What do I say? Dwight?
Student?
Student.
New student. Is that it?
Yeah.
Right? Just like we've already done, it's just using a user-defined data type instead of a primitive data type. Clear?
So that's an instance of student?
This is now, we have just dynamically allocated one of these and placed its address in here. However, ID, FName, LName, gender, GPA don't have anything in them yet. Right? We've just allocated the space. Can I do this? Allocate an array, 100 long, of actual students. Nothing in each one, but allocated nevertheless. Space for it is allocated. Questions there? No different than what we've done before. One very subtle, simple little change changes the entire world here. I put a splat there, and what does that do?
It turns into an array of pointers.
It's an array of pointers to what? It says it there.
Students.
It's an array of pointers to students. No, we don't have those students allocated yet, but we have the array to hold the addresses. Now, I want to talk about size difference. Here, new student 100. How many bytes in an integer? Somebody that's good with math, I'll ask Andrew. Most mathematicians, I find, can't add 2 and 2 very well. Hopefully Andrew's better than that, but nevertheless, Andrew, will you keep count for me? That's 4 bytes for the integer, plus 25 bytes for this, 25 bytes for this, and a single byte for char, and 4 bytes for the float. How many bytes do I have in one struct?
59.
59. Okay? Now, therefore, this one allocates, statement here, allocates how many bytes? 5,900, right? Now let me just change this to be a splat. Now how many do we allocate? How many bytes do we actually allocate? 4 for each one, and 100, so it's 400. 59 down to 400. Is that clear? All just by putting a splat there. We have to be very in tune with reading these things very carefully so we see that if there's a splat there or not. Okay? Now, if we had this and we just did, instead of this rather large thing, we just said new student, how would I go about putting a value into ID? And that'll be the last thing we'll do today. I want to put a value into ID.
Dereference.
Xpointer.id.
Pardon me?
Xpointer.did.
Xptr dot ID equals 3456. Does everybody agree with that? Kenan doesn't. I agree with Kenan. What is it? The problem is that in the notation before, Q here was statically allocated, wasn't it? It's fixed. Xptr is a pointer. And so we have to introduce some new notation now. Get used to it because you're going to see this a lot from here on out. Arrow notation. Let me read it, and you read it backwards when you read this. So you're going to assign 3, 4, 5, 6 to the ID member of, that's the arrow, member of the structure pointed at by, that's the rest of the arrow, Xptr. So reading backwards, I say 3, 4, 5, 6 is assigned into the ID member of the structure pointed at by Xptr. Clear? Makes sense if you know how to read it. Okay, right? We good there?
Yeah.
All right. Slight difference, but a huge difference, really. Questions? See you Wednesday.